This is John Pa, and I'm here to present a data analysis for some employee data I got, focusing on predicting employee rate and attrition. There's three sets of data that I received. The first set was a file containing employee data with attrition and monthly rate present. The second set was a smaller set where the monthly rate was missing, and the goal is to predict the monthly rate. The third set is another smaller set where the attrition is missing, and the goal is to predict the attrition. All these files had the same columns, and none of the data was missing other than the monthly rate and attrition as noted. So first, looking at the effort to predict monthly rate, the average monthly rate for employees was 6,500, and this is a right-skewed distribution. Our goal is to predict the monthly rate with a root mean squared error of less than 3,000 and minimize it if possible. Looking at the data first, in terms of the numeric fields, there was high correlation between the monthly rate and the total working years. There was also correlation with age, years at company, and the other years fields. And all of those fields correlated with each other as well. For example, total working years correlated strongly with age. In terms of other numeric fields that predict the monthly rate, having a higher education, being in the sales department versus the human resource department, being in marketing as education field, which correlates with the sales department, or gives you higher income, or being in human resources gives you lower income. Also, one of the interesting findings was that having a lower work-life balance also meant you tended to have a lower rate, but it could be the other way around, that the employees with the lower work-life balance also had less income. It's hard to tell what causation is there. So I used a linear model of those parameters to predict the monthly rate, and this shows you the significance level for the different parameters in the linear model. So age, the ones that are highlighted in blue are the most significant. Age, job role, and years at the company had the highest significance. I used this model. Well, what I did was I took the training data, the combination of training and the data with no attrition, which had the monthly rate, and I iteratively created test train splits to see how well the linear regression model was able to predict the monthly rate for the employees in the test data set. And I found that the average rate was 1,865. So this is well below our goal of 3,000. The next goal was to predict employee attrition. And this goal is a bit more challenging because we want to maximize both the sensitivity and the specificity and have those values both be above 0.6. And most of the employees tend to stay, so the attrition value of yes was much less common, less than 20%. And this is looking again at the full big file, and as well as the monthly rate file where the attrition was present. In terms of factors that predict attrition, the overtime was probably the biggest factor. Not all employees have overtime, but those who do have a much higher attrition rate, particularly the laboratory technicians, research scientists, and sales executives and sales representatives in particular. If they were getting overtime, they have much higher attrition than their peers who weren't. Another factor was the stock option level. I'm not sure what these stock option levels mean, but stock option level of 0 and stock option level of 3 had much higher attrition values. So perhaps switching employees over to the stock option level 1 could be done. It seems like quite a few employees have that. Stock option level 2 had very low attrition, but there were much fewer employees in that category. Other factors that were important for predicting attrition were the frequent business travel, having an environmental satisfaction of 1, education field of human resources, and being single. One factor that did not predict attrition, which was a surprise, was performance rating. The performance ratings of employees who were and were not attrited were almost equal. The first attempt at predicting attrition was to use a naive Bayes model. This model had good results overall, but it had a low sensitivity of only 53%. The next model was the random forest technique. This model also resulted in only an average sensitivity of 14%. So I had to reject both those two models. The third model I used was logistic regression. I first used an AIC to automatically choose parameters, and then switched to a model where I could choose the parameters because it allowed me to do cross-validation. The parameters I used that had significance were age, business travel frequent, distance from home, environmental satisfaction, job level, job roles, number of companies worked, job satisfaction, and stock option levels, and of course overtime. So there's quite a bit of different fields with significance there. So the challenge, like I mentioned, was that we want to get the maximum sum of specificity and sensitivity. And I found that we also want to have the value be above 0.6, as you can see the bar in the middle. So I found that if we set the threshold around 0.15, I was able to achieve those results. The threshold measures how sensitive the model is to applying the attrition label to the different categories. So the conclusions: predicting the monthly income was straightforward using the linear model. I didn't attempt any further models, but predicting attrition was much more complicated with the low sensitivity for the naive Bayes and random forest models. It could be that there's other solutions to this in terms of the data. One of the ideas was to use a 50-50 test split to try those models, but I didn't have time for that. Using the logistic regression model allowed me to tune the model by setting the threshold, which was particularly useful in this case. It would be interesting to try further models to see if we can improve the sensitivity and specificity with them, especially models that are more easily tunable. That's it. Thank you very much.